All right, let's dive in. We're going to talk about a piece of technology that is, well, pretty much everywhere these days: large language models, or as you've probably seen them called, LLMs. I mean, who hasn't heard of Chat GPT at this point, right? You've probably played around with it, and it's kind of mind blowing. You ask it anything, and poof, a super detailed, weirdly human sounding answer just appears. It really does feel like magic. But is it magic? What is actually happening behind that simple chat box? Well, that's exactly what we're going to break down. We're going to peel back the layers and see what makes this whole thing tick. So, let's get into it. So, first things first. To really get a grip on this, it helps to have a simple way to think about it. So, let's imagine an LLM as a computer brain. Yeah, a computer brain. Keep that idea in your head because it's going to help us make sense of everything else. Okay, so let's get the official definition out of the way. What is a large language model? At its heart, it's a specific kind of artificial intelligence, and it has one big job: to understand our language and then create text that sounds like a human wrote it. Simple as that. And this is where that computer brain analogy really clicks. See, this brain isn't just programmed with facts. It learns. How? By reading. And I mean reading. It's been fed a truly insane amount of text. Billions and billions of sentences from pretty much the entire internet, countless books, articles, you name it. Okay, so it's read more than any human ever could. But so what? How does all that reading turn into it being able to write an email for you or even write computer code? Let's really get into the nitty-gritty of how it pulls this off. And here's the most important thing to understand right up front. It is not magic. And it's not a thinking, conscious being. Nope. Under the hood, it's all just math. Really, really complex math and statistics. It's a giant, powerful, pattern-matching machine. So how does this math actually work? Well, you can basically break it down into three main steps. First up is training. This is where it's fed all that text, and its only job is to learn patterns. It's basically figuring out which words tend to show up next to other words. You know, like how after the sky is, the word blue is a pretty good bet. The second step is where the action happens: prediction. When you type something in, it doesn't think about a whole answer, no way. It just makes a guess about the single most probable next word, or even just part of a word, which they call a token. Then it looks at what it just wrote and predicts the next most likely token, and the next and the next. It builds the answer one piece at a time. And finally, there's context. This is crucial. It keeps track of the whole conversation, so its one word at a time predictions actually stay on topic and make sense together. Okay, we keep throwing that word around: large. Large language model. But what exactly is so large about it? It's not just a cool name. It actually refers to two very specific things that are just gigantic in scale. So, what are those two things? First, the sheer size of the data it's trained on. We're talking a massive, massive library of information. And second, something called its parameters. The easiest way to think of parameters is like the brain cells or the neurons in that computer brain. They're what the model uses to store all the complex patterns it learns. Let's try to wrap our heads around the scale of that data. If you decided to sit down and read everything, every single word that a big model like GPT-4 was trained on, it would take you thousands of years. I mean, just think about that. It's a completely mind-boggling amount of information. And what about those parameters, those brain cells, the really big advanced models? We're talking trillions of them. Trillions. That incredible number is what gives the model the power to handle really complex questions and understand all the little nuances in language. And here's the wild part. With that many parameters, strange new abilities, like being able to reason through a problem, just sort of emerge. All from the simple task of guessing the next word. All right, so that's the theory, that's how it works. But what can you do with it? Let's talk about the real-world stuff, the practical ways this technology is already being used every single day. I mean, the list is getting longer all the time. It can help you bang out that email you've been putting off, or even write an entire story from scratch. It's an amazing translator, converting languages in a heartbeat. For programmers, it can write and fix code. And get this, you can feed it a super long article and just ask it, "Hey, what's the gist?" And it'll summarize it for you. It's a huge boost for getting things done. And of course, you know the big names. There's ChatGPT from OpenAI, the one that started the whole craze. But then you've got Google with Gemini, a company called Anthropic with their model Claude, and even Meta, Facebook, has Llama. They're all a bit different, but at their core,
They all work on the very same ideas we've been talking about.
Whew, okay, that was a lot. So let's just zoom out for a second and put it all together. Let's recap the whole thing from start to finish, nice and simple.
When you get right down to it, it's a three-part dance. First, there's the input. That's just you typing in your question or your command, your prompt. Then comes the process. This is the model's brain whirring, making a lightning-fast chain of guesses. What's the next best word? And the next, and the next. And that creates the output, a complete, sensible, and surprisingly human-like answer. From your prompt to its answer, that's the entire journey.
So there you have it. It's not magic, it's just math on a massive scale. It's not thinking, it's predicting. And it's definitely not just some science project anymore. It's a real tool that's changing how all of us work and create things. So now that you know the secret behind the curtain, the real question is, what are you going to do with it?